Hey everyone. If you clicked on this video, it's safe to say that you're looking to build and ship amazing mobile apps with one codebase. Well, we have some great news. In this video, we're going to show you why you should be building and shipping your next app for iOS and Android using Flutter and Firebase. I'm John, a developer relations engineer for Flutter.
And I'm Seth, a product manager for Flutter. First up, we're going to give you a quick intro to both Flutter and Firebase.
Then, we'll take a technical look into how Flutter works and how it's different from other multi-platform solutions you may have used. Then, we'll dive into some demos that show you how to bring various features to life in your own apps, like this one.
We're going to start by doing a quick introduction to what Flutter and Firebase are all about. What drives us and our whole community is our commitment to helping developers like you build beautiful apps for all users. So we built Flutter, the world's most popular multi-platform app SDK. Flutter is a highly productive open source development stack complete with language, framework, and rendering engine that helps you bring to life high-quality production-grade apps that run great across iOS, Android, the web, and more. The Flutter community and adoption of Flutter is growing every day. There are over 50,000 packages in our ecosystem. Over 1 million developers are using Flutter to build over 1 million apps in the Play and App Stores. In fact, 30% of new apps in the App Store are built with Flutter. We're thrilled to see the community bring Flutter everywhere. So, what do our developers, teams, and businesses find so valuable about Flutter? Or, let me rephrase, why should you care about Flutter? Your users are everywhere, and you want to reach them everywhere with your investment. So we made Flutter truly multi-platform. It runs your apps from a single code base across iOS, Android, the web, and more. Your users want beautiful experiences, and you want to deliver your business's strong brand consistently across all form factors. We want to help you always say yes to your designers. So we made Flutter's framework flexible and powerful, so you can create anything from UI that looks like the built-in apps on iOS and Android, to more branded, creative designs that match your company's design identity. We're delighted that so many development teams have crafted fully custom brand-specific design languages and app experiences with Flutter. Your users want delightful animations and smooth interactions that keep them in the flow. So we made Flutter fast and efficient. Flutter is backed by a complete, custom, multi-platform rendering engine that is able to support advanced graphics and smooth animations. And you want to rapidly develop, test, and deliver new features and fixes for your users. You want to experiment quickly to validate ideas. So we made Flutter very productive to work with. Hot Reload is the flagship feature that gives you sub-second dev cycles while iterating on your app. And it comes bundled with a great set of dev tools, so you can dig in when the unexpected happens. Your users want featureful apps that leverage the best of what mobile and the web have to offer. You want to take full advantage of your favorite and popular app development SDKs to enhance your app's abilities. So we made Flutter extensible to integrate with your host platforms and work with any SDK. Now, before we jump into the demos, let's take a look at how Flutter works under the covers to deliver high-quality, feature-rich apps. Flutter's architecture is actually quite different from what you might expect. Where some other multi-platform frameworks wrap the native UI widgets in a shared API, in Flutter, our rendering talks directly to low-level graphic APIs. And where some other frameworks are powered by programming languages that require just-in-time compilation, Flutter apps are compiled ahead of time directly to native machine code. Let's look at each of these layers. At the top, we have the Flutter framework. This contains our core widgets that you use when you write an app, things like buttons, rows, columns, and colors. If you're familiar with any declarative framework, you'll see the code is easy to read and understand. The programming language in Flutter is Dart. It is a modern, object-oriented, strongly typed programming language. So developers with experience writing Swift or Kotlin will feel right at home in Dart. We'll talk more later about why we decided to use Dart. Next, there's the engine. This contains the Dart runtime. It also contains the graphics engine, which has all the primitives that the framework needs, such as text layout, pixel rasterization, and event handling. Let's take a closer look at Dart here. We sometimes get asked, why did Flutter pick Dart? Well, there were two guiding principles or requirements that needed to be met. First, the best choice for a very fast development experience is to use a programming language that can be just-in-time, also known as JIT, compiled to machine code while the app is running. That way, you can see your changes almost instantly during development and rapidly iterate. Second, we think the best choice for apps with a rich user interface is to use a programming language that is ahead of time, also known as AOT, compiled to machine code when the app is built for production. That way, when an end user launches the app, it's ready to run at full speed instantly. Dart checks both of these boxes very nicely, and so it was a perfect fit. Also part of our engine, our renderer talks directly to the low-level graphics APIs in the platform host, just like native frameworks. It basically converts rendering commands into rendering pipelines that can be run directly on the graphics hardware for the device. For example, on Apple, we create Metal render pipelines under the hood. On other platforms, we use Vulkan and OpenGL. This means your Flutter apps are running right on the GPU for maximum performance. And finally, there's the platform embedder. This is the only part of the architecture which is platform-specific. It connects the platform-agnostic engine to each host platform like iOS or Android. The embedder architecture also allows us and partners to bring Flutter to more places and more platforms. Okay, there you have it, a quick technical tour through Flutter. We hope you saw that Flutter's architecture is built to deliver on the value proposition we shared earlier, and how it is different from other multi-plat offerings. For an even deeper dive into how Flutter works, check out Craig's new video series, aptly named How Flutter Works. We'll have the playlist linked in the video description for you to check out. Now that we have a sense of what makes Flutter special and how it works, let's put Flutter to work with some demos to build a real app. We've built this custom-designed, beautiful multi-platform mobile app called Compass. Compass helps you book amazing trips around the globe. Users can log in, search and filter for destinations, and book fun activities. We're going to show you 4 key experiences when building with Flutter. Our fast, productive developer experience, how to use our framework and built-in widgets, how you can integrate with the host platform, and finally, how you can integrate with Firebase services. As you know, productivity or developer velocity is paramount. It doesn't matter that you can create beautiful, fast apps if it takes forever to build them. So here's the scenario for our first demo. We met with the designer and they have a few notes and tweaks we can make to the design. Hey John, do you mind helping us make these UI tweaks?
Sure thing, Seth. Let's make some changes to our app. We're going to use VS Code, Flutter DevTools, and Hot Reload so you can see how to debug and make changes to your Flutter app. So let's take a look at all the tools Flutter provides to help you. Here is Visual Studio Code with the official Flutter plugin installed and my iPhone. You can see that the Flutter plugin adds various tools to the sidebar, which we'll see in a second. So we've got some feedback on a particular screen in the app. So let's check the look and feel of our booking screen. These chips tell the user what types of activities this destination has. But it looks like we're getting an overflow error, which is indicated by these yellow and black slashes. I'm going to open up the widget inspector and enable select widget mode, which lets me click directly on the widget I want to look at. The widget tree view shows a simplified view based on the widgets I'm using in my code, and I can select them to take a look at their configuration. In Flutter, each widget is given constraints from their parent widget. These constraints define the maximum available space that a widget can take up. So let's look at the parent widget to see why there's not enough space for our chips. It looks like the problem is that this row widget is overflowing. In other words, the children are taking up more space than the row can provide. If I use a wrap widget instead and save the file, Flutter updates the app right away. That's because Flutter can hot reload the app. It's a stateful hot reload, so the app stays on the same screen and I can make changes to the real app while it's running. I also want to add spacing between the chips. To get more information about this widget, I can go to definition by holding the command key or control key on Windows and Linux and clicking on any symbol to see where it's defined. I can even see widgets that are in the framework, which means that I can read the API and documentation to find the parameter that I want to use. Let's use the spacing and run spacing parameters to make this look nicer. Dart's formatter formats the code, indentation, and trailing commas. Cool. Now I can see a warning because I added the parameter after the children parameter. This is called a lint rule, and it helps you enforce best practices in your projects. A lot of the diagnostic messages like this can be fixed automatically using a quick fix. Let's apply this quick fix to keep things consistent with the rest of my project's code.
Thanks for showing us Flutter's developer tools, John. Now that we have made a couple of UI tweaks to the app, and we have a sense of our fast dev cycle, let's add something a little bit more substantial to the UI and UX of the app. Before we do that, let's talk a little bit more about our framework, which is the set of APIs you use to build UIs. One of the things we've focused on in the framework is giving you the building blocks organized into layers to build the design vision you or your designer might have. Flutter was designed to give you a lot of power and flexibility and lets you access an escape hatch to go down one level if you need to for further customization. Or you can build on top of the framework and use the bundled widgets. We've implemented 2 design languages that you can use out of the box, Material and Cupertino. When building for an Apple device, you may want your app's toggles, nav bars, lists, and menus to look like the system apps. This is where our Cupertino library comes in. This demo is open source and built by a member of our developer community using our Cupertino library. Delivering high fidelity is important to us. We use the official Apple Figma files and various other techniques and custom tools to ensure that your end users can't tell the difference. Flutter's framework lets you mix and match these Cupertino widgets with any custom widgets or custom animations you want. You can also create adaptive apps that use Material Design on some platforms and Cupertino on others. For our next demo, here's a scenario. We did some user studies with Compass, and we learned that some of our users on iOS would really love a familiar UX pattern when booking their trip. John, can you add that in, but only for those users on iOS?
Sure. Let's check out some of the different ways that we can customize the look and feel of our app to match the platform. Here, I have my Android and iOS devices, both running from my VS Code project. Once I select some of the activities in the app, I can navigate to the booking screen, which lets me book my trip. This looks good on Android, but I'd really like to use a sheet that transitions from the bottom of the screen on iOS so that the experience matches the platform. Here, you can see I'm checking the platform to decide what type of transition animation to use. The Cupertino sheet route lets me show a native-looking modal bottom sheet. There are a lot of other ways to customize the look and feel to match the platform too. For example, we can customize the transition animation to fade in on iOS and fade through on Android, using the animations package from pub.dev, our official package repository. There are a lot of widgets that match the platform's design language available in Flutter. Here's a switch that looks correct on both platforms. We've also made this date picker, which matches the look and feel of the native date picker. These tweaks aren't required for your app, but it helps your users if you show them a widget that they already know how to use. We're really excited about the possibilities here for developers. And we're working hard to make sure Flutter supports high-quality apps that provide a great experience for your users no matter what platform they're using.
Thanks, John. It's great to get the right look and feel on both platforms. Flutter is, at its heart, a multi-plat way of building apps. However, one of the common misconceptions that we hear is that multi-platform frameworks lead to lowest common denominator apps. Fortunately, that's not the case. Flutter apps can very much take full advantage of the underlying mobile platforms. Let's see how Flutter integrates with and uses the platform so your apps can really shine in the ways that are special on iOS, Android, and more. Flutter's ecosystem has a rich set of platform plugins already available to you, with over 5,000 plugins just for iOS ready for you at pub.dev, with thousands more for other platforms. These plugins wrap the underlying platform APIs to make them really easy for you to use. For example, here's a list of the most commonly used packages for iOS integration, for things like in-app purchases, camera access, and lots more. All of these have been updated to use Swift Package Manager too. If for some reason you can't find a plugin for the SDK or iOS API that you want to use, you have 2 options for how you can access the underlying platform APIs directly. First, you can use method channels. These are an async message passing mechanism between the Dart code and the platform. Let's see an example of how the battery level plugin might work under the covers. We can send a message from Dart to the iOS host requesting the current battery level. Then on the iOS host, we can call the platform battery API. Finally, we pass the result back to the Dart side. Method channels work great if you just need to call a few APIs. But for larger API sets, we have a second option. This is a new tool called FFI-Gen, which automatically generates bindings from Objective-C headers and JNI-Gen for Java interop. Once you've run the generator, you can then call directly into the APIs from Dart, like this example here, where we're calling into the standard Apple audio APIs in AVF Audio. This example used Objective-C, but we're currently working on extending this to cover Swift too. Again, you don't always have to write interop code. There's a good chance that you can find what you're looking for in our over 50,000 packages available on Pub. So, knowing that we can access pretty much anything in the platform, let's give Compass some awareness of the user's geolocation so that we can narrow down nearby activities. John, can you help us add this new feature?
Yeah. Say we're adding a new feature like geolocation. We want to make it easy to find activities near you by requesting your location using the native location API on each platform. To do this, we need to make sure we have the geolocator plugin installed. We can use the Dart command line tool to install it from Pub. We've actually already installed this package, so this is telling me there's nothing to change. We can also open up the pubspec YAML, our package configuration file, to double check. Now let's open up our search screen so we can start adding this feature. Tapping on this widget calls the getCurrentLocation function, so let's fill that out. The async keyword makes this an asynchronous method, so you can write your code as if the program execution stops at this point and continues when there's an await in front of another asynchronous method. But under the hood, Dart is managing an event loop, and our app is running on a single UI thread. This function communicates with the host platform using the plugin, which calls the correct platform API on iOS and Android, but it's using the same Dart code. Great. Now, when the app asks for permission and the user grants it, we filter the list of destinations based on your nearest continent. And if you need to create or modify your own plugins, you can fork the many open source packages like this one, or even write your own, to interoperate with the platform APIs as you see fit.
Okay, so we have our Compass app, and its UI is looking great, both on iOS and Android. We have some nice platform integration going on, and we've been using hot reload all along. We're feeling good. But we can't launch the app just yet. We need to persist the user's activities across devices and sessions. For that, we can use Firebase.
Firebase is an opinionated and easy-to-use platform that helps professional app development teams work safer, faster, and smarter. Firebase offers a suite of services and APIs for you to build your app, run it, and engage with your users. You can even use Firebase without Flutter. After all, we believe it's important that developers have the choice to pick the best tool for the job. Our teams work closely with each other to make sure that Flutter and Firebase work great together. They're sort of like chocolate and peanut butter. They're great separately, but they're even better together.
Here's the setup for our final coding challenge. Users told us that they want to start planning a trip and pause any time without losing their work. For example, they might want to ask their friends for some advice. To solve that, we need to save the user's progress to the backend as they go, so they can come back later and pick up right where they left off. Cloud Firestore is a perfect tool for the job. John, what do you think?
Cloud Firestore is going to work great here. But first, we need to add Firebase auth so that we can store data for each user. So let's get started. I've already installed the Firebase command line tool and ran Firebase login to authenticate my development machine. These are the standard Firebase tools you would use with any app you're building, not just Flutter. Next, I'm also going to install and run the Flutterfire command line tool to configure my project. Now I can install the Firebase packages I want to use, in this case, Cloud Firestore and Firebase auth. I also need the Firebase core package. Now we're ready to write some code. Let's start by updating our auth class to use Firebase auth. Firebase auth is really useful because it lets you add sign-in features that support various types of authentication, such as email and password, Google, Apple, GitHub, and more. In this case, we're going to start with anonymous sign-in so that we can keep developing our app with a real user, but without the need for a real email or account. This is great for prototyping, but it's also useful in production apps if you want to allow users to use the app first and then upgrade their account to use a different type of authentication later. Now I'm going to print out the user ID so I can make sure everything is working. Great. Now we can use Cloud Firestore. In this app, each user has a collection of booking objects stored in a collection. I can take a look at the Firebase console to get a look at my database and see the changes happening live. Now, let's save our data to Cloud Firestore when the user taps on the Book button. We also need to subscribe to this collection by listening to the snapshots so that we can show the user's booked trips on our booking screen whenever they book a new one. And there you have it. In just a few minutes, Compass supports sign-in using Firebase Auth and uses Cloud Firestore for fast, scalable, real-time updates.
Wow, Flutter and Firebase really do work great together. It was really fun to watch how we quickly added new UI and features to our app and saw it all working across iOS and Android. Great work.
Thank you.
To wrap up, let's recap. We saw Flutter's great developer productivity with features such as hot reload and DevTools. We also saw how Flutter's optimized for crafting creative user interfaces that can be brand-specific, yet still feel right at home on each target platform. Going beyond UI, we saw how Flutter lets you integrate with the target platform using plugins, so your app can take full advantage of native APIs. And finally, we combined our Flutter app with Firebase. We used Firebase Auth and Cloud Firestore to enable login and data syncing features on all platforms.
If you're interested in learning more about Flutter, head on over to flutter.dev to get started. While you're there, you can even check out some of the real-world Flutter apps in our showcase. For example, Google apps like Google Pay or YouTube Create. Recently, we were excited to share that Wolt, Universal Studios, and Virgin Money are also using Flutter to build their apps. We'll include a link to the code for the Compass app in the video description so you can check it out if you're interested. Thanks for watching. We hope you found this video helpful. If you're building and shipping your next mobile app with Flutter, drop a comment below and let us know. We can't wait to see what you build.